we can start. I see already a lot of people connected, and others are still joining us. So let me just start a short introduction. So welcome once again, everybody, to the Plenary Talks session. I'm very honored to introduce Professor Juan Manuel Corchado, and he is the first keynote speaker at the ISM 2021 conference, and he is going to give a talk about smart development of IoT management systems for Industry 4.0. Just before giving the stage, the virtual stage, to Juan Manuel, let me give you a short introduction about him. So Juan Manuel is full professor at the University of Salamanca, a very well-known and highly cited scientist in the field of Industry 4.0 with an H index of 46. He was vice president for research and technology transfer from 2013 to 2017, and the director of the Science Park of the University of Salamanca, the director of the doctoral school of the university, and also elected twice as the dean of the Faculty of Science at the University of Salamanca. In addition to a PhD in computer science, he holds a PhD in artificial intelligence from the University of the West Scotland, and he is visiting professor at Osaka Institute of Technology since 2015, and visiting professor at the University of Malaysia. Juan Manuel is also the director of the European Iot Digital Innovation Hub and of the Bioinformatics, Intelligent Systems and Educational Technology 11 Research Group, which he created in 2000. He's the president of the AIR Institute, academic director of the Institute of Digital Art and Animation of the University of Salamanca, and has also been president of the IEEE Systems, Man and Cybernetics Spanish chapter. He also oversees different master programs and has supervised different PhD theses, author of over 800 research peer-reviewed papers and books, and chaired several conferences, and is editor-in-chief of several journals in the field of Industry 4.0. So thank you once again, Juan Manuel, for joining us, and please feel free to share your screen and give your talk.
Thank you very much, Antonio. Thank you very much for your introduction and for inviting me to be here with all of you. I hope you can see my screen.
Yes, perfect.
Yes? Very good. Okay. So I'm going to try to stick to the time I have, which is around half an hour. And since in half an hour is not possible to go very much into details, what I pretend to do is how I envision our future in this research field. And I'm going to introduce you an idea which is quite novel, at least for the Spanish standards, that are allowing us to grow as a research group, and especially to get involved in very many industrial projects of great interest to us. So as Antonio introduced, I am the leader of, or the director of the research group at the University of Salamanca, which I started when I came here around 21 years ago. And we are a little bit unusual because we are an interdisciplinary research group, and we have in our group around 140 researchers, PhD or people working on their PhDs, and they are all working with me in different projects. I will introduce you some of the projects they are doing with me. So in order to be able to strengthen our structure, we have created the AIR Institute, which is a research center recognized by our region. We started with it 2.5 years ago, and it will be, hopefully in the next few months, will be recognized as research center at a national level. We have on it around 50, well, exactly 52 people, most of them with PhD, but some of them are already progressing into getting one of a PhD. And we have especially a majority of the people of the people involved in both the Air Institute and the Visitor Research Group are doctors in computer science or artificial intelligence, but we have engineers of all kinds, mathematicians, physicists, even philosophers, biologists, and so on, because of the nature of our research group is very broad. So in order to be able to join forces with other research labs and with other companies, we are leading the Iot Digital Innovation Hub, which is was the first one created in Castilla y León, which is the region where Salamanca is based. Salamanca has quite a lot of industry, although we don't have a lot of population. Although it's the second biggest region in Europe, our population is quite small, around 3 million people. But with that structure, we have been able to bring together with us a lot of new research opportunities, and even get involved with other companies from abroad, and with other research groups and universities. And now all the digital innovation hubs of our region are joining forces in the DGS3, which is led by us also. And with that research group, digital innovation hub, we are trying to make the structure of our research centers and our universities in the region, in collaboration with our local government, is stronger. Also, we believe a lot in the education. Obviously, we are a university, and as such, we do a lot of constant learning courses like masters and so on. And for example, we are running the Cyber Wall Academy, which is the one of the teaching academies of the Spanish National Police Force, and this is especially focused on cybersecurity, and we are running it in collaboration with the National Police. And given just to give you some information, our major strength is the artificial intelligence, but we are divided into research units that help us to provide and to develop product in collaboration with industry, but to go up to the end of the product. We don't just develop a basic or fundamental research, but also we go into the prototype, but if needed, we can deliver the full product, the full commercial product. That help us especially to get closer to the small to medium enterprises and to provide them what they are looking for. They cannot develop with their own resources because they don't have enough experts on AI, or maybe they don't have any on cybersecurity and so on. So we have different units within our research group and within the Air Institute on cybersecurity, on data science, machine learning, IoT, bioinformatics and neuroscience, blockchain, fintech, intelligent textiles, and also we work a lot in smart cities, smart grid, and obviously in Industry 4.0, which is one of our biggest areas of research. Basically, now we have around 150 projects, around 30 of them are European projects, but we have a lot of projects which are direct subcontracting from some of the from industry, from the banking sector, from hospitals and pharmaceutical companies and so on. So basically, again, one of the major strengths, and that's why we are very competitive in this field, is that we have our own algorithm, our own suite for or implementing solutions, which I will show you in a minute, that allow us to extract the most from the data, but also from the knowledge existing on a given problem. You see, most of the people that are working on data science, for example, just base their work on analyzing data using a network, a neural network, or analyzing data using a given algorithm or statistics and so on, data that are there on a database. We believe in most of the cases the solution require additional information, require knowledge from experts. So we have a number of products that help us to extract knowledge from the experts on the field, and a number of products that allow us to use the data that is stored on the databases, but also when we solve problems, we know that normally we can use real-time data from sensors or from any given source, but also we can use models that second parties develop in the future. For example, if we want to identify how it's going to evolve the price of the oil, we have obviously information about the past, but we have also information from experts on the oil sector, on the energy sector, but we have information about the regulation of the given countries. We have socio-political information that are on the newspapers, and that is there for us to analyze. But also we have models that some organizations make about how the oil prices are going to evolve in the next few months or even years, according with different situations. So what we do is we try, in this example, to model all of this information to provide a reliable solution to our partners, and also not just to tell them what is going to happen, but to explain why we think that is going to happen. So we try to create artificial intelligence that evolve with the problem and that explain what it does and why it's been done. So I think that is the future of AI, especially the future of AI in the industry, because the industry requires a lot of solutions to be more efficient, especially in Europe. And Industry 4.0, the concept of Industry 4.0 is especially, okay, let's get the most of the data we have, and let's be more efficient than the others, because, for example, others have lower prices or cheaper labor force, or I don't know, maybe more resources to develop what they do. But we can be efficient because now we have the intelligence to provide very intelligent solution in a way, taking the most of all the data available, and even the data that is not available but can be simulated, but also about the knowledge of experts. Okay, this is the basic concept I want to transmit you, because that's why we are, for example, working with companies like Airbus or some other large companies that have a lot of data scientists on their inside at home, but they, in a way, develop a kind of open innovation solution with us, because we are able to provide this extra element that it's important to create a difference, to be able to create something really useful and that is more realistic, because the world is very dynamic and we need to implement solutions that evolve with time. So in that sense, we are now in an amazing situation where we have communication networks that allow us to communicate with all machines at the industries, even at home, at the city level. We have cloud systems that are very reliable, secure, and provide us a lot of facilities to develop products. And also we have the blockchain, which is an element that help us to to provide more trustable solutions, because we at any point we can show what has happened in the past without any potential possible manipulation, and so on. And also it's important to show that there are hundreds of, if not millions, of potential areas where our solution can be implemented to make a better solution, or to deploy a better solution, or even to solve a problem that is already there affecting people, and most of them are related with the sustainable goals. So basically, AI has evolved a lot, as you can see from the past. We started someone started a long time ago with artificial neural networks, with expert systems, with genetic algorithms, and this system have evolved a lot. And also we have another type of potential solution to problems, especially very good in control, like fuzzy logic. And by the end of the last century, we understood that AI should be distributed. The distributed artificial intelligence was the way to solve this most of our problems. And we had, for example, this beautiful book that I translated to the Spanish market, called Artificial Intelligence: A Modern Approach by Russell and Norby, that provide us another way, a different way to solve some of the problems that were there, using distributed AI, for example, with the concept of multi-agent systems. But also, apart from the multi-agent system, we have another element, like, for example, social machines that allow us to create solutions in collaboration with these computers, so humans, and have a partner, which is a computer, which is for example, providing solutions in collaboration with a machine and machine tool, and we have been able to create large projects in the past. So actually, in a way, by the end of the century, you remember, if you are old enough, like I am, we were all thinking, oh, what is going to happen? We were a little bit bored with AI, because we were a little bit stuck, no new ideas, no nothing. We could solve traditional problems like identify, for example, noise signals and so on, recognize some pictures, recognize some tumors, but nothing else, nothing specific at that point. With the change of century, the computer science was booming, and we, most of us, like me, stopped doing AI just to get some money and working with companies that needed just management software to develop other things. But then suddenly, again, when we were, at least myself, were a bit in the middle of the desert, lost and forgotten about AI, I saw again that AI has a lot of potential. And in that sense, with projects like, for example, ImagineNet, and with all the explosion of internet, where we saw that we could have access to millions of data sets of, for example, of pictures or information and so on. We decided that, okay, let's see what can we do with all of this information. And someone thought about, for example, this is one example of many, of deep learning and the convolutional network by systems that are very clever, actually, that allow you to for example, classify huge amount of pictures by convoluting and pulling pictures. We duplicate the picture, we modify with different filters the picture, then we reduce the size. So at the end of the day, we can identify picture of boats because they have boats, picture of dogs, picture of cats, in a very, very easy way. And with mathematical model, we required a strong computer system, but we had, because they were developed, obviously, and they were accessible to us from companies like Amazon or Google and so on, which are making a lot of money now with this storing all of this information. Most of the cases we don't know why, but we keep storing data there. But some cases is useful, some other is not. But in that sense, we were able to transform images with relatively simple algorithms using convolutional network, and to be able to, for example, identify what there was on an image more accurately than a human could do. In and a few years ago, those type of algorithms were able to outperform the solution of human solutions. So that changed a lot, and that has made AI fashionable. And it's not because it's fashionable, but because all of this has attract a lot of industrial people to understand what is AI, and they are demanding a lot of solutions to us. And then that's why, for example, my research group went from 12, 15 people in the last few years to almost 200 people that are now working with me in different solutions at a very high level. So we have, as I said before, all of this potential. We have a lot of possibilities, and we have now solutions. Which are those solutions? Basically, we have hundreds, thousands of algorithms. That's another clue I want to tell to give you. We have an AI observatory within our research group, and we are continually especially with our PhD students, looking for new solutions. We don't need to invent them. We don't need to develop them, because there are hundreds, thousands of AI scientists providing us with beautiful solutions every day, applied to different problems. So what we try to do is to get to know basically all the algorithms that are there that we can use, and that are providing good results on a given problem. So that's something very important. There are a lot of possibilities, and we need to know which of those algorithms are better for which type of data set. So we have a classification of algorithms, and then any point we know all the families who have developed those libraries, and for example, where can we use them, and all the peculiarities of this. So when we approach a given problem, the first thing we do is to say, okay, which type of data we have, which type of knowledge we have, what can we use to solve the problem. And in that sense, what we try to identify the best library, the best algorithm to use on that given problem. What we have seen also, just for your understanding, by reading papers from our colleagues, that most of the research group among their own life do not use more than 6 different types of algorithms on what they do. So people keep using the same algorithm on different data sets or similar data sets. Maybe they evolve the algorithm a little bit, but some of the cases they just are kind of very just focus on one neural network, for example, or a fuzzy logic solution, and just try to apply that to everything. Okay, it's very important to understand the data, to see if the data is completed, to filter the data and to treat the data in an adequate way, and then to find the best algorithm, because I don't think the solution is just to use whatever we know. The solution is using on the different data sets the best solution depending on the dimension of the data, the amount of data we have, the number of for example, variables of a given vector, and and so on. So that's very important in that sense. So another important thing is the communication, because we believe all the information, especially at industrial level, that is there is data that has to be moved from one place to another, from sensors to the cloud, from one computer to another to take the decision, from a smart hub to a computer where again to take a decision and or to present a dashboard. The interfaces are not just computers anymore. They are mobile phones, they are tablets, they are anything actually you can imagine. So it's important to take into consideration the communication protocols, because obviously it's not the same Bluetooth than Wi-Fi and whatever, or a LoRa, for example. We need to develop a solution that will be able to take the most of the present communication system, but especially now to the communication system that are going to appear, sorry, in the near future, because this is a very active field, and sometimes we are surprised about how we have access, for example, to new data sets that require a given bandwidth to access to them, or they have a particular latency, and also some communication networks that sometimes are very expensive, and then suddenly appear another that are free, and so it's important to develop AI product thinking in all the potential sources and how the access to that sources is going to change. So in that sense, for example, one of the elements we have developed is a smart PCB for developing edge computing. Okay, I'm sure you are familiar with this concept of edge computing and edge computing, which is basically bringing the artificial intelligence to the edge of the network. And in that sense, we have developed a board in collaboration with Texas Instruments that allow us to run complex AI methods on a little board that can be used in the industry sector, that has the peculiarity that can communicate almost with any existing communication system or protocol nowadays, from LoRa to 5G to Wi-Fi. We are exploring 6G also, and all the system has something important, which is need to be secure. We have strong security measures, encrypting model, but also we encrypt everything we read on, introduce everything we read on this board on a blockchain, in order to be able to distribute the information and to make sure that it has been untouched in the past. So that type of system, you need to incorporate them on architecture that are sustainable and that basically allow or provide you with flexibility. Okay, one of the problems we have in Spain, for example, is like in most of the countries, we have companies that has been there for many decades. And for example, with this company, Sonai Arauco, they do good boards for companies like IKEA, for example. They have a large manufacturing company near Salamanca. And basically they have machine tools or production lines from last century, but some other are from this century. So they all need to work on a stable way, working 24 hours a day, 365 days per year. And they need, for example, solutions for predictive maintenance. So we need to have elements flexible enough to be able to incorporate to any of those machines and to create a full product for them that then is scalable for any of the manufacturing sites they have worldwide. And basically for that, you need an architecture that allows you to read data from any sensor, our sensor, but also sensors that these machine tools have already, share that information and manage the AI from the edge of the network at the level of sensor, but also in the cloud when you have the whole information you need to solve a given problem. So we have adapted, for example, this product to outdoor solutions, indoor solutions, to different to a variety of sensors, and it's important, as I said before, to provide nowadays trust on our partners, on our clients, a refutable proof, and to guarantee the data integrity. And blockchains, Ethereum, we also work a lot with Tron, are allowing us to show our partners that, okay, we can do the full traceability of everything we do, and you have access to everything has happened in the past, and you have the guarantee that nothing has been changed or transformed. And for that, we do a lot of, in that sense, we try to present, for example, everything we do to our society. We have a course that is, as I told you before, developed in parallel, a program with the National Spanish Police, but it has a private area just for the police forces, but also a public area. So all of the interesting things we do in that sense are showing to anyone in this course, which is open to everyone and is for free. And also you can have a diploma from the university. So all information, for example, all protocols or algorithms or everything we develop, us or our partners, with related to cybersecurity, for example, is open, information open, recorded on video, and transformed into a course that is open to anyone. This type of courses we started this year in July, and we have had over 1,000 students only in these 5 initial modules, and we will be doing providing new courses along 2022, and we expect to have more than 500,000 students worldwide. So in case you are interested, for example, in cybersecurity and how cybersecurity can be used in networks or in architecture, or can be used in collaboration with AI, or can be used, for example, on the IoT systems or Industry 4.0, you can access, and you have a lot of video developed by more than 400 collaborators here. So it's important, the dissemination. We do the same on the field of AI in different projects like this one. So it's important to listen what people is looking for, what is the reality telling us what is there. And in that sense, we thought, okay, let's try to put together a system that allow anyone to develop a strong AI systems, and has already what is an element that normally take a lot of time. For example, something to read information, something to store information, something to apply artificial intelligence, something to create a dashboard for that. So we have developed this tool, deepin.net, which is a tool you can access. Also is for free. It has for free with some limitation. Then if you need something else or to provide to use it at an industrial level, you have to pay a fee. And we have developed that product with a number of companies that help us to develop very fast solutions within months rather than within years in the fields of Industry 4.0, in the field of automobile, electric automobile, for example, in smart city fields, in the energy field sector, and so on, because it's a tool that allow you to create dashboards with all type of potential views with the data, but also read the data from any source, any relational, non-relational database, any web page, any sensor, anything you want, to visualize the data, to apply AI, different models for classification, supervised, not supervised, for predicting, and so on, and then to create interesting and easy-going dashboard. So it's important in that sense that you feel that the users need a product well connected, and that's why, for example, DeepInt, but there are many other tools allow you to connect with any sensor, any database, any visualization tool at the right cost, because you need to provide solutions fast and cheap for the customer. So, for example, I'll show you some of the products we have done in the past few years with different companies. For the banking sector, for example, FinPredict is a product that allows us to tell the bank on an airport how many clients is going to have on a given day, and to identify what type of currencies are they looking for, and how much money are they going to change in a given currency, which is we are working with the biggest company, which is called Global Exchange in the world, and they have improved the efficiency significantly using this type of algorithm that have substituted manual protocol they have. For example, this is another product we have done, which allow us to monitor the behavior of mouses, when we apply the different gases and they drink different liquids. And it's a little product, but that we have been able to develop with very cheap technology. You can see here is a computer science. There are some electro valves in here that we have developed ourselves, and well, we can deliver this product for a couple of €100,000, while the product that they were using in the neuroscience center of Spain for analyzing this type of thing, the product in the market had a price over $30,000. So the price reduction is significantly, and we are, for example, commercializing this type of product in collaboration with them, because we can provide it for scientific research very in a very cheap way. So this is another product we do. It's an implant for hamsters. For this again, we are working in different projects related to epilepsy, and we have that's how we started. This bottom battery. This implant goes behind the skin and connected to the vagus nerve of the hamster, and basically we identify signals that appear on the hamster brain before they are going to have an epilepsy episode. So basically we stop it. So again, this research was doing with a human product, which the cost was around €20,000, and now the cost of developing this product and package it just in a very homemade way is not more than €30. So you can see the difference and how many more experiments they can do with this product rather than with others, a commercial product. This is a smart lamp. This is a product we have developed for the a medical research center in Spain that take care of sicknesses that are very contagious, especially in tropical areas, and just by analyzing the warm blood, what we do is we warm up the blood that is mixed on a little kind of bottle with another product. We warm it up, we see how the color changes. It's very simple. It's using lamp technology. We connect it with the mobile phone of the doctor. We can identify if someone has up to 7 different contagious diseases, and we move immediately all of that information to a cloud in order to identify epidemic. So this is been in this product is under use in Africa and Colombia, in the Colombian self, and it's been tested, and hopefully it will be industrialized soon. So this is again a product that we can bring to the market, building one by one by a couple of €100, and now that we are industrialized, the process will be even cheaper than that. So it's a product for the science, but also it's a product for the medicine at a reasonable, very reasonable price. So we are working on next generation genomic with a South Korean company called Thelemics. We sequence the whole full genomic, the genome of a person. Basically, our product is different than the others in the market. What we want to do is, okay, a doctor identifies someone has a potential sickness, given cancer, asks them to make an analysis with, so we obtain a fast Q. They can do a biopsy, or they can have a blood analysis. That information is moved into a fast queue in the lab. Then our system, what it does is read this fast queue, align the genome of a given person, just clean everything, and eliminate those things that are wrong. And then, depending if we have a germinal or a somatic analysis, we work with different AI algorithms and machine learning protocols, and basically are able to identify anomalies. And this is where we are now, identifying the anomaly. The next step, what we want to finish by the next summertime, is to say, okay, these anomalies are compatible with this sickness, and for example, if there is a problem in the KRAS gene, this is compatible with breast cancer, and this is the treatment you require. So it's a product not for the labs, but it's a product for doctors of medicine that help them to identify potential sicknesses directly from talking to the patients. Okay, so the product is very advanced, is under evaluation with different hospitals, and hopefully in 2023 it will come to the market. So Hermes is another project where we are. One of our largest projects is actually led by our colleagues in Italy, but also it's $10 million project, where we have partners in Germany and in the UK and Switzerland and Sweden, and basically where we are analyzing what happened in the human brain before an epilepsy episode appear, and how we can deal with that. So we are focused on working on the data analysis. There are some other groups working on the nano components, and some other working on the mother cells. So important for us, very important, is one of our largest projects is this one with Airbus, where we can identify with them how many passengers are going to have on a given new airline. It's important, the system was running very nice until the pandemic started. Then we have to adjust it, obviously, because everything changed. And now we are using it to companies, airplane companies, to identify how they can reopen the lines they closed in the last year. So we, for example, capture information related to gases on train stations, and then we provide information with our own sensor in order to improve the quality of life of the workers there, the passengers, and so on. Platinum, we monitor these companies I told you before. I think I am running out of time, isn't it, Antonio?
Yes, just if we can conclude, so we can have a couple of minutes for question and answers.
Yes, so I can show you some other. We are helping this company, Tecotham, or to provide a more efficient way to build bridges, and especially to guide the launching countries, and basically we do a lot of traceability on the wine industry, and okay. And for the smart farming, the rabbit industry, we basically measure how the rabbits are growing and so on, and how much they are eating to keep it stable. And farming, industrial farming or precision farming, it's something very important to us, and is attracting now the attention of our products are attracting the attention of many farmers, and we are growing there a lot. So thank you very much for that, and I will be happy to answer any question if there is any.
Thank you very much, Juan Manuel, for the very interesting speech. Of course, everyone is invited to open the microphone and make questions. So please also use the Teams functionality to raise your hand in case you have some requests or you want some additional information about the institute that Juan Manuel presented. So I can see already 2 questions. Please, Vittorio. I see already Peter. Peter, yes.
Well, my question is whether do you have some acquaintance with recognizing COVID infectious people by some smart textile or by some wearable clothes? Because this is very actual to recognize from breathing or whatever. So whether you have some acquaintance with this?
Oh yes, we have had 2 projects. One is with the government of Panama, and then the second one is with the government of the area of Caldas in Colombia, where they asked us to develop a product for them to identify the evolution of COVID, and how they could reassign resources to different hospitals or centers depending on the evolution. So this platforms are under use, and there are some public websites where you can see what we have done there. And basically we develop a model based on convolutional network with some SIR models combined. It's a kind of hybrid system where we use historical data, but also information about all the new restrictions that the government were imposing to the citizens.
Okay, and some intelligent textile or wearable?
Not textile, not wearable. We have developed two stations that are for use on the entrance of buildings. Is when a kind of cabin where you enter there, and the cabin measures you the temperature, your weight, your appearance in case you change from one day to another, measure several elements, and the body temperature, they have a pulsioximeter, and provide just that type of information. Nothing else with the other kind of intelligent textiles and so on.
Anyway, it's interesting, even this cabin. Maybe I will contact you later. Thank you.
Of course, yes, anything you need. Thank you. Thank you.
Thank you very much, Peter. Antonio, I see as the next question.
Yes, thank you, Antonio. Good morning, Juan Manuel. First of all, I would like to thank you for your very interesting presentation. I have just a quite general question. In the first slides, you mentioned the concept of blockchain. Since the first edition of this conference, we have collected some papers about the blockchain, which is a very interesting topic for our audience. What do you think about this technology? I mean, because it looks very promising, but perhaps it has not yet reached a large-scale diffusion. In your opinion, are there any barriers to the spread of this technology? If yes, which one? I would like to know your point of view about this technology. Thank you.
Okay. Thank you for the question. Actually, blockchain, we started blockchain around 4 years ago, where we received a couple of Russian industrials that were looking for someone to develop some cryptocurrencies for them, and for a business they were developing in Spain, in Mallorca, which is an island in Mediterranean island that you probably know, very touristical. And we was everything a little bit weird, because we normally don't receive Russian people in our lab, and also are asking us for developing a currency. So we thought, we told them, sorry, we don't do this type of thing. Actually, we don't know much about cryptocurrency, but okay, a few weeks after, they contacted us again, and we have 4 or 5 different companies asking us to help them with some cryptocurrencies and some blockchain. So I thought, let's try to start with this technology, and let's see what it is. And then we started to work with Ethereum, and then with Tron, and we easily and very soon we started to think how we can use this technology for traceability, to develop trust. And now we have over 20 projects where we are developing a traceability product for the wine industry. We have we have one of the Spanish biggest winery, and they have a full traceability system. For example, they have information on their blockchain about how much the liters of water they need to grow each grape, but also they know who is drinking the wine in Japan when they say where the bottles are being opened, and so they can control the market very well. So we do the same for the meat sector. In Salamanca is the biggest area in Spain for producing cow meat, and we have a full traceability system. So we know if the cows are vaccinated, the type of food they eat. We can, at the end, at the customer's level, tell them, okay, this is first class meat, second class meat, whatever, or the meat comes from abroad. And we also have developed a product which is a kind of YouTube channel. Okay, it's not a channel on YouTube, it's the same structure that you can see like YouTube or Netflix, which is called Notion, Noision. It's a television platform that behind it everything is on blockchain, but also we have developed a token which can be a cryptocurrency to make a business out of that. So people can sell their product, anyone can access to that system, put their product and commercialize them using cryptocurrencies. And we are thinking to change to develop our own cryptocurrency with that, which is a kind of token that has the value of the commercial product that is on the television platform. So for traceability, I believe it's a great product. Obviously, for cryptocurrencies, it is something moving a lot of money, so it's already there. It's a success, a business for many people. I suppose some other are losing also money with this type of things, but in that sense, I think the potential is very, very strong. And also, for example, we are now working. It's a potential project. It's not a project already, but there is a government willing to use blockchain for monitoring the election process, and we are working on a prototype for them. If we succeed, it may be a full product later on. So I think it's a reality. It has a lot of potential, at least, for example, in traceability and so on. But the first thing that people tell me every time that they ask me for blockchain, how much is going to cost me to have a blockchain? Because we are thinking that mining is something related to blockchain for the Bitcoin and so. No, it's not really. No, you don't need to mine in all blockchain. You just need to develop an infrastructure to monitor what is going on, to share it, and to distribute it. So private blockchains, I think they are something easy to put it together nowadays, to implement for traceability. You can create great products without much effort. It's not expensive at all, and it doesn't cost money for the final user.
Okay, thank you.
Thank you, Victoria. Thank you.
Very exhaustive answer. Thank you very much.
Thank you.
We have maybe a couple of minutes just for another question. Michael, please.
Okay, thank you. Thank you, first of all, for your great talk. I agree in very many points, especially when it comes to integrating the human expert, the domain expertise into machine learning processes, especially within industrial applications. I was just wondering a bit that I had the impression that in terms of methodology, you seem to have a very, very strong focus on neural network-based machine learning techniques in your lab, because we are making the experience that when it comes to structured numerical data, as we very often have it in industrial application when dealing with sensor values or so, then especially when focusing on interpretability of models or explainability of models, then other techniques like symbolic regression are often very accurate in interpolation and maybe even in extrapolation, not on big data, but rather on small data, maybe a couple of 100 or 1,000 observation points, but offer this additional interpretability right away. Do you also use such kind of methods, or why do you have such a strong focus on neural network-based techniques?
Good question. Basically, we just try to use what is best at any given problem. And normally, we work with this concept of hybrid AI. Basically, we normally, most of the problems are actually, I would say, all of the problems we deal with have many different data sources. We have the data, we have what is around the machines, which is around the city. We have external information that we can use. We have information about the users of the machine and so on. So use a combination of different algorithms always that they can go from statistics. Sometimes a simple statistic is good enough, but sometimes it requires a convolutional network. But normally, what we do is a mixture of experts working together, different elements working together. So, for example, in prediction, the SEER models work very well for pandemic and so on. But there are many other factors that are not in the numbers, are around everything. The government standard, what is happening in Spain with this COVID is being influenced by how the airlines act and by how the measures that are run in the airport. So we have many different data sources, and we try to use as much information as we can. And also we have the knowledge of experts. For example, when we do predictive maintenance, what we are working with a company here, which is they do chemicals, but natural product from vitamins to other type of things, and they have different areas within the company that they don't have interconnection, so even the responsible of the machine tools cannot move from one area to another. So the knowledge of that guy looking after that machine is very important. When we do predictive maintenance, we need to extract the knowledge of that guy. It's not a matter of just reading data from analyzing data. We need to see what type of knowledge this guy has and to model it. And then sometimes we use an expert system, sometimes we just simple rules that can assist what a neural network says or a fuzzy logic system says or whatever. So the options we have are very broad, and something we do also, which is very important. When you try to solve a problem, you need to do a strong brainstorming before anything else, with a large or reasonable large number of experts on AI with different experience on that. Because something I feel for myself is like learning a language. You can learn the theory, but until you don't reach a number of years trying to talk, understand, you don't have the feeling of communication. So it's important with AI to get the feeling of AI. Okay, I mean, you can apply a neural network on a given data set to construct a fuzzy logic system, but you need to understand if, as you mentioned, can we interpolate? Is this algorithm better to extrapolate? How can we classify? We can classify it with sense, with common sense, with this algorithm, or we need something else. So it's important that a number of people with experience, and that's what we do. We have around 60 people experts on AI, which I know they have different feelings. Some of them like more one type of algorithm, some other. I always put them to work when we have a problem. We spend, first of all, a few weeks to understand the problem, to see how much data we have, to see how we can treat each type of data set, how we can merge with some others. And then when we think on the solution, we just apply it. That is not a major deal. We have tools to do that. But the important is not just to go and apply an algorithm. It's important to select the best algorithm. As you say, Mitchell, we are not biased toward, maybe I just put too many examples of artificial neural networks, but we are focused on identifying the best data set, all the information we have about a project, and how we can take the best of them with different algorithms, or the different combination of algorithms.
Thank you very much. Unfortunately, we are really running out of time, so we have to move to the next speaker. But I would like to thank you once again, and also here's the the certificate of appreciation from all the ISM 2021 organizing committee. So of course I will deliver this certificate to you later on by email. So thank you once again for this very interesting speech. I would like just to leave maybe with your own words to listen to our reality, as you said.
Okay, thank you. Thank you, Antonio, for inviting me to be here with you. Thank you very much. We're in touch.
So, and now we can move to the next speaker that I already see. So, hi, Sophie.
Hi.
So, just a very quick introduction. So, I'm very glad to introduce the second keynote speaker. Is Dr. Sophie Parkner. Sophie is a R&D engineer at the Process Engineering Department of IRMA Recycling Machinery. After the bachelor and master program in polymer technologies at the Johannes Kepler University in Austria, he finished her PhD thesis in 2019. And the main topics have been modeling, optimization, and further development of continuous extrusion, recycling, and filtration processes. At IRMA, she's working as a R&D engineer and is responsible for external research cooperation and scientific partnerships. And the main focus is on interdisciplinary process engineering development, as well as in the area of application-oriented research and development. So her talk today will be about digitalization as enabler for circular economy, use cases from the industry's point of view. So please, Sophie, feel free to share your presentation.
I will do so.
Wonderful.
So you can hear me and you can also see my presentation.
Yes, we can.
Okay, thank you. So right at the beginning, thank you very much for the invitation, for having me here, for the interest in an industrial point of view for different topics. So as Antonio already mentioned, my name is Sophie Parkner, and I'm working in the process engineering department at IRMA Recycling Machinery. I will afterwards give you a few words about our company, what are we doing, and so on. And I'm going to talk about digitalization as an enabler for circular economy. I know digitalization is a very big word, and if you Google it, you will get a lot of different definitions for it. But especially in the field of polymer recycling, a lot of topics are related to digitalization, maybe not in detail what you all are doing, but therefore I wanted to show you today two use cases where the scientific work found its way to industry and where it is now implemented and is very helpful in the recycling business, so let's say. And right at the beginning, I need to tell you, I'm not a data scientist, I'm not developing algorithms and so on. So I studied polymer technologies, so I'm dealing with plastics and the processing of polymers and so on. So maybe a total different background than the speaker before, but I hope I can give you some nice information. So I want to give you just a few slides about our company. So we have here the IRMA group, who is the head, so the holding structure, so to say, where we have different companies located. So the biggest one by far is the IRMA Recycling Machinery, where I am also working in. Our headquarters is in Austria. We have about 750 employees worldwide, but most of them are located here near Linz in Austria. We have different companies who are dealing with the development of recycling machines for polymer recycling, but we have also different business units and companies who are producing, for example, key parts of our machines and so on. So here you can see two examples of our machines. So the whole group with its single companies are developing and manufacturing very highly efficient plastic recycling systems. I have a few slides afterwards to explain you how these machines are working, how, for example, post-consumer waste is going to be transformed to regranulates in order to drive the circular economy in terms of plastics recycling. So just to give you an idea, since 1983, I think, the foundation of ARIMA, more than 7,000 systems are sold worldwide, and they are still, 7,000 are still running. So a few of them are already exchanged to new generations, of course. They are sold worldwide, and they are producing a lot of regranulates. I think it is about 14.5 million tons per year. And you can see we are having our technology all over the globe. But at first, before I start with my talk, I think not everybody of you is really familiar with the topic plastics. I think I can think of that a lot of you already heard always in the media that plastics are bad, they are bad for our environment, for the animals, and so on. Therefore, I want to give you just a few words about why this raw material is very important for our modern life. So, polymers, of course, is a relatively young material, especially compared to steel, for example. But it's very innovative. You can do a lot of things with it, and it's very important for our modern life. We never need to forget that a lot of things which are possible in our everyday life wouldn't be possible without polymers. So especially when you think about nowadays in the pandemic situation, so without polymers, medicine would look totally different. So it helps us to save lives. It helps us to reduce CO2 emissions, for example, as we can build lighter cars and airplanes and so on. And of course, it offers us a lot of functionality and security in our daily life. But the most simple thing is our clothes. So without polymers, we would have troubles then. Of course, there are a lot of packaging examples who are really stupid. I totally agree. So yeah, it's always depending on what we are doing with it. But of course, in our business, the waste, so the packaging which is thrown away, is a really high quality raw material for us and for our customers, as a lot of products can made out of it again. So within ARIMA, we want to really close the loop to give plastics a second life. But now a few numbers again to just show you, of course, plastics are important, but of course a lot of problems are caused by them. So there is a quite nice study who are dealing with how many plastics has been produced since I think the 1970s. And out of this, there was 6,300 million tons of plastics waste, which has been generated. And just 570 million tons of it has been recycled. So some of the material, of course, is still in usage for when you think about the buildings industry, for example, window frames or other building constructions. But this number is really scary. So because this means still about 5,000 million tons of plastics waste is still in our environment. And this is not what we want to have. So we need to rethink our usage. We need to give the people the possibility to use their waste and not to throw it just on the street, for example. So therefore we need to rethink, and therefore also digitalization can help us to improve our processes. And right at the beginning, I want to show you what are the challenges in polymer recycling. Where I think all of you agrees, we don't want to have scenes like they're showing here, and we need to change. And in polymer recycling, we have a lot of challenges. So we have input material streams. So think in Austria, we have the yellow bin system. So where all the post-consumer waste is collected and then manufactured in different processing steps. So when you're thinking of such a waste stream, you have a lot of contaminations in it. This can be stones or steel or aluminium, but also sand or glass. So a lot of contaminations can be in the material. We have different moisture contents. We have different shape of material, different layer structures, polymer compositions, and so on. So that's the topic we are dealing with every day. But okay, I'm not sure if, okay, now it's the noise is way. So, but what is the challenge? Most of the customers want constant quality. Of course, they want constant mechanical properties, color, shape, optical properties, and so on. And of course, they want it constant and they want a high quality and of course a high throughput because they also all want to earn money. And how to overcome this challenge is you need to be very flexible. And therefore, on the one hand side, we have our machine technology. I will show you later on. And we have different quality on devices. So we have measurement systems who are measuring different quality parameters right during the production so that we can rearrange some settings of the machine when we see that the quality measure is leaving its specification. But we also have different digital solutions already implemented. I will show you a very short overview about it. So we have always the goal out of making the varying input material to a very constant high quality of the output material. And this is what our machines are looking like. So we have here at first the preconditioning unit. So the material is entered after this conveyor belt, and then the material is cut, it is dried, it is heated up already. It is homogenized, it is compacted, agglomerated. We have the functionality of a buffering inside, so we can adapt the residence time of the material inside this PCU. So this is one really key part of our machine. Afterwards, tangential, we have the extruder. So here the still solid material is entering the extruder. The material is further heated, then it is molten, so it's getting liquid, and this is happening through different screw designs. And then the material is molten, and then we have liquid polymer, which can afterwards be handled again. So we are now filtering the materials, so we are removing different types of contaminations. Like already mentioned, sand particles, aluminium, and other contaminations which are still in the material. And afterwards, we have the granulation or the palletizing system, where we then again producing pellets out of the material, which are then ready for our customers to be sold to the converters or to the direct converting. They are then ready to make our products out of the material again. And the two use cases I will show you today are about the palletizing system and the filtration system. Just to give you an overview about the machine, and so I'm going to talk about the in material flow direction, the last processing steps. So, but why do we think that digitalization can help us to overcome the challenges which I already showed you? So we see a really strong benefit in our digitalization activities, especially in more efficient networking, right starting within our company, but also within the polymer industry. I will show you later a picture how many processing steps are included in the really mechanical recycling of polymers. But of course, it's also necessary for our customers and our suppliers. So we are working on different topics with a lot of scientific partners, where one topic is also the development of different data analysis tools, which we are already using, because we think that this offers us very great potential, not only for us as a REMA, but also for our customers. So we can develop different analysis, and also our goal is always to develop different assistance systems. So therefore we can now optimize our recycling process. We can optimize our machinery, of course. And for the customer, this means we have an improved product quality, maybe reduced energy costs, increased throughput rates. So very important for our customers. digitalization also helps us in order to create new business models for us, but also for our customers, as we also are providing them more solution competence. So every data analysis is also very important for our customers, because then they understand the process better and can act better on the machinery and in order to increase quality parameters. We already are running different digital solutions. I have just mentioned it two and very short. So we have our own MES system where we are collecting all the data of the machines. It's called Re360, from machine to desktop. So we have there the possibility to collect all the processing parameters of the machines, but we can also include their quality parameters and so on. And this tool was very important for the two use cases I will show you later on. This was the base for all the modeling approaches which we have done together in cooperation with the colleagues of Hagenberg. We have another system, the Blueport performance platform. This is an online platform for every customer where we are offering different apps in order to analyze the data. You can have there a look in the long-term archive. We provide them a Polymer assistant to help them find the best settings of the machine. He can have a look at his key performance indicators and so on. So these are really big tools already, and they help us also in the development of new products or processes. So now I want to show you our research activities. We have a lot of them. And I will show you just a few. At first, I want to mention the LIT factory. I don't know if you have ever heard about it, but it's a really big building at the Johannes Kepler University in Linz. So they have built a smart factory where a lot of machines are placed of different suppliers, not only recycling, also different polymer processing machines. And there we have also placed a machine. You can see here the picture. And we are using this platform really as an interface between science and business. There are scientists and guys of our company or other companies are coming together and working together on different use cases in order to get application-oriented and cooperative research. Because we see that this is very important also to make people feel that polymers are not bad. It's always the usage, and that polymers can be a very good raw material, or even if they are already a waste. And we have placed a machine there which is producing about 300 to 600 kilograms per hour. So for us, it's a small-scale industrial machine, but it's very important for us. The university can handle it quite good. But for us, it is important always to have industrial scale, because scale-up of process and machinery is very important in our industry. So we need to build even bigger machines all the time, and upscaling is therefore very important. But we also have different cooperations and networks along the entire value chain. We have a lot of projects there. Just to mention a few, we are also participating in the CHASE consortium, where a lot of companies along the entire value chain are partners there. So we want to work together there to promote the very fast and efficient circular economy. We are working on different use cases with our partners, and we are working a lot in cross-disciplinary research, where we have experts of different disciplines bring them together, because we see this is very important, especially also in the activities which I show you later on. And we are always looking for new partnerships and collaborations, as we really want to drive the circular economy, and of course to improve also our digital solutions. Therefore, we think that data visualization and analysis are very important features. So we are using it to validate our processes or to find unstable conditions. Very often, you cannot see it if you just have a look at all the process parameters on a snapshot, or just a fingerprint. You need to have a look over a longer period of time. And very often, we can then find unstable conditions which are caused by some material changes or some defects on some sensors or so on. So we are always interested in finding unknown or hidden relationships. Therefore, we have different projects. Out of this, we want to, of course, derive optimizations in our machinery, in our processes. We want to develop new control strategies by using very modern modeling techniques. A future goal is also to predict different events. Maybe you can predict an event if you have a look at the data. We are working already on this. And especially in the process engineering department, it is very important for us to have tools to compare different machinery and processes. It's not that easy in polymer processing. Polymers are behaving very, very different in comparison to, for example, water or so. So we have a lot of effects which can be simultaneously, and you always need to have a look which effect, which material property, for example, caused which defect, and which machinery change leads to which change in the end product quality. So therefore, this is a very big point for us, especially in developing new parts of the machine. Therefore, also very important for us to validate our different process conditions, for example. But now, this brings me to the two use cases I brought to you today. So at first, I will show you one which is done in cooperation with the colleagues of the University of Applied Science in Hagenbeck, the team of Professor Kronberger, where we have modeled the throughput performance of our machine based on experimentally determined data. And I have a total different example where we have modeled the flow through woven screens in melt filtration. This was done during my time at the university and was part of my PhD thesis. Based on numerically determined data, we developed models to predict the pressure loss of filtration systems. So the first use case about the throughput prediction. In a first step, the goal was to determine an executable model to control the speed of our granulation system. So the goal of our customers and of us is always to have a uniform pellet size and weight of the pellets, which are produced right here. So you have here the melt, which is entering, you have a die plate, and over the die plate, you can imagine like spaghettis are coming out of the different holes. And then you have knives who are running and cutting it into very small pieces, so very small pellets. And of course, we want to have them all in a quite small range of size, because then it's easier for our customers in the further processing. So if you have then variations in the process, it is hard to arrange the speed of the granulation system. And therefore, several models existed already based on, for example, the screw speed. Another one controlled the speed of the granulator by the screw load or by the melt pressure. But we wanted to have a new approach which combines different parameters, as we know that not only one single parameter influences the granulation. So we used a new approach. My colleagues, and this work was done before my time at the RIMA, my colleagues did a lot of experimental work. So they used different machineries, they used a lot of different materials. You can see here different input material streams. They did a lot of tests, so they changed the process parameters, the process settings, and so on. So in total, I think it was about 350,000 data sets for the developing of the models and the evaluation afterwards. And therefore, I already mentioned, we had a cooperation with the guys of the University of Applied Science, and we used, they used Heuristic Lab and applied symbolic regression to find a model to predict the speed of the granulator by using different parameters of our machines. I'm not sure if these are all. They did a lot of work. They did great work. And so we had a model which was able to predict the granulation speed, which could be used then by us as a control strategy. And this brings me already to the point you can see here. We had to predict the throughput of the machine. And therefore, the same model could be used for the throughput prediction. I will show you later on. Here you can see some results. You can see here the green line is the granulate weight at the set point. The existing model is the black one, and the red curve shows based on our regression model. And what was the best point is that we had some significant process changes. So the process has changed, for example, the humidity of the material, and this was also always recognized by the new model strategy. So we had a better accuracy of the new models than the existing models. And we saw that it is more independent of external influences, as we can see changes in the process with this model, with other models maybe have not recognized. And all the actual processing parameters are considered. And we did also a lot of trials on different machines and setups, and also different machine sizes. So scale-up was again a very important topic, and it was working very good also there. And as already mentioned, sorry, the model, it was the same model which can be used for predicting the throughput of our production lines. So not every customer has a mechanism for getting an information about how much material he's running right now. So the throughput of the machines is, of course, a very important parameter for every customer, because this means money for them. And not every customer has the possibility to measure it right during his process. So it was a very, very important feature. We are using this model now in terms of a soft sensor. It's already implemented in a lot of machines, and predicting the throughput. So we did a lot of test runs in order to see if it is fitting the results which we are getting back from our customers, and did some modifications of the model, but we see a very high accuracy and very happy customers that they have now a soft sensor which shows them the throughput capacity of the machine, which of course is affected by a lot of different parameters of the machine. You can see the system is very complex, and you have a lot of possibilities to influence the throughput, but we have now a possibility to model it, to give the information to our customers. It's good information for us, and of course we can now derive different control strategies if we know exactly the throughput performance of our machines. So, for example, which I showed you before, the control of the speed of the granulation system. Yeah, I forgot to mention. You can see here the throughput, which was measured by a throughput scale, is the black line, and the red line is the predicted throughput by the models. And you can see a very high accuracy. And we are using this system now for quite a time, and we are getting very good results from our customers. This brings me already to the second use case, which I will show you. It was the modeling of the flow behavior in melt filtration. So we wanted to have an executable model. So for us, it's always important that the models are executable. So we want to derive control strategies. We want to implement them in calculation tools and so on. And therefore, it was a goal to describe the throughput pressure gradient relationships of polymer melts, which are flowing through woven screens. So you can see here such a filter, where these woven screens, metallic parts here. So the melt is flowing through and the contaminations are then in the sieve, and you can change this screen. We need this information about the pressure and the throughput behavior for the layout of our filtration systems. And therefore, we did a lot of different calculations. There are a lot of models already existing according to literature, but every of it is not, so not everybody, no, so a lot of these models are not considering the especially non-Newtonian flow behavior of the materials. So therefore, we again used a different modeling technique. At first, we did a lot of physical analysis, physical modeling. I will not go into detail. This was a lot of polymer engineering work. We defined some elementary cell and some different parameter studies. And then we did a very, very huge numerical calculation. So we did run CFD studies to have a really big database, which then was used for the modeling approach. So we again used heuristic lab and symbolic regression to build our models. And in the last step, we validated the models with a lot of experimental work. So here the modeling was not based on experimentally determined data than before. Here we used numerically determined data. And we then, after all the modeling, we had a lot more than, I think, I don't know how much data point it was, but it was, I think, way over 10,000, which was used for the modeling. We got some equations like they're shown here, and we got a very high accuracy. So with our models now, we were able to predict the simulation result very, very well. So this was just the first step. So we need to have a look does this model and also the simulation, of course, now fit the experimentally determined data? And therefore we have done a lot of experimental work also. We have used different machines, different screen changer systems, materials, screen types, which you can see here. And we were measuring the process right before and after the melt filtration system to get a big data set for the validation. And we found, again, a very high accuracy of our model. So we can see here, it are called P-screen models. We have an absolute error, a mean absolute error of about 7 bars. This was also a modeling approach of us, which was quite similar, but this was models according to literature. You can see here we have about 14 bars mean absolute error, so we are outperforming them in terms of accuracy. And our models are even simple in handling. So we were able, by using, again, heuristic lab, to predict the initial pressure drop of woven screens. We are using it very often, this model, these different models for the layout of the filtration process and the pressure calculation, so that we get an idea how big does the filtration system needs to be for our customer, because we know which pressure we can have right at the beginning. We have samples of the materials, and therefore now we have the possibility to calculate, to scale up our results. And because this model is very, very fast and stable, and it was quite easy compared to the other models to implement it in our expert system. So with these two use cases, I wanted to show you how the scientific work found its way to industry and how it is used there right now in our daily business. And this already brings me to the outlook of my talk. So we have still a lot of potential for digitalization and modeling approaches in post-consumer or mechanical recycling. We have a lot of different processing steps like shredding, pre-sorting, washing, again sorting, then extrusion. This is the step where our machines are used. We have converters. A lot of them are already collecting data. But I think we have a lot of work to do there in order to model the processes, to optimize the processes, and the most important thing, to exchange the data and the information along the entire value chain. So if we would have information about the washing conditions and the condition of the finally washed product, so maybe the humidity content, we could arrange our extrusion system so we can find better set points then. So just, I think a lot of you are working in the field of digitalization and so on. A lot of work needs to be done in the polymer recycling industry. So we think, this brings me to the end of my talk, that cross-disciplinary research offers a really great potential in polymer processing. We are always looking in combining different experts, polymer technologists, chemists, data scientists, and so on. Of course, it's not always easy making them speak the same language, but we, I think, found a good way to do it. And in our business, we see a lot of potential for all the analysis and visualization of the processes, as I already showed you before. If we would exchange the data along the entire value chain, every partner could get a big benefit out of it to improve his process. And also, these modeling techniques helped us to describe the very complex processes in polymer processing, also in order to derive control concepts, to improve process and machinery, and of course, as already mentioned, for the customers to optimize the quality of the regranulates, to reduce energy of the machines, to increase the throughput, and so on. So this brings me to the end of my talk. So our company has a great vision for the year 2030. So we want that circular economy for plastics is reality, and therefore we want to be a very, very central partner in achieving this. And therefore we have still a lot of work to do with great research partners, which we have with the team of Professor Kronberger. Thank you very much again. And I'm now open to answer any questions. Please do not hesitate to contact me also by, I think you will get my contact information if you have any additional questions which we cannot handle right now.
Thank you very much, Sophie, for the very nice talk. I guess that the topic is extremely relevant nowadays, considering all the strategies for sustainable industrial development and for all the circular economy hype that we are living. So, if there is any question from the audience, please feel free to raise your hand and open the mic and camera. So I see a question from Vittorio.
Hi, good morning. Thank you, Antonio. Thanks, Sophie, for your very interesting talk, for your very interesting presentation. I agree with Antonio, the topic is very relevant and very interesting for us. I have, I think, a bit technical question about the first use case you presented. In a part of the first use case, you mentioned the use of symbolic regression based on genetic programming through heuristic lab for predicting, I understood, different parameters about your use case. I have just a curiosity. Have you also tested other methods, such as, for instance, artificial neural networks or other machine learning techniques, or only genetic programming? And in any case, did you plan to use also other methodologies in the future to have a better accuracy? I don't know. Thank you.
Thank you for this question. So as this work was done before I was entering the company, I don't know for exactly, but I know that the team did a lot of work in choosing the right algorithm for the analysis. But of course, we have other projects where we are using different modeling strategies. But in our case, the executable model needs to be at the end. So we need to have an equation afterwards to use it for our control strategies and so on. This was the main topic. Actually, I cannot answer it right now. I cannot tell you which methods they used also. So
Okay.
actually, I don't know, unfortunately. But we have other projects where we are using other modeling techniques as well, yes.
Okay, thank you. Thank you.
I see another hand raised from Gev. Hi.
Hi. Thanks a lot for this wonderful presentation. I'm really interested in the circular economy and especially also on process analysis statistically. How big of a factor is explainability in your modeling procedures? So of course, in the end, before we go to complete automation, there will be some process controllers who will have to accept what comes out of the prediction models. So
definitely.
Yeah. How big is that? For choosing the algorithms, where do you want to be? Do you want to be like in the neural nets and just hope that everything goes well, or do you want to go more to the PLS type regression stuff?
Yeah, actually, we have very strong partners for these topics. We are not doing the algorithm works by our own, of course, because we are a machine builder, but they explain it. So we always want to have models which we can understand. So we do not want to have black box models, for example, as we know the physics of our machine very well. So therefore, it would be always good to have a model which we can analyze and have a look, can this be? So is it a possible, physically possible result which we are getting out of it? Not always that easy, of course. But we also want to have assistance systems. So we want to give the operator of the machine the possibility to choose, is this what you get from the algorithm? Do I agree with it or not? So we do not want to overrule them, the operators of the machine, because they have the best knowledge about the process.
Okay, thanks.
Is there any other question? Yes, I see Michael.
Okay, can you hear me?
Yeah.
Okay, that's fine. I was not sure because I'm in the car at the moment. I would like to add a point because our group has been part of this project, which fits, I think, to both of the last questions, where we work with, after having tested numerous techniques, where we came up with genetic programming-based symbolic regression, which, based on our experience, is able to produce especially good results if there is some natural science background in the system which we are modeling, because the hypothesis space is mathematical formulas, mathematical terms without a priori assumptions about the structure of the nonlinear models. And I personally think as mathematics is the natural language for natural sciences, more or less, that's one good explanation why for applications with a natural science background like physics, chemistry, metallurgy, so this kind of techniques work especially well. And apart from this, they can be interpreted pretty good, that which is also relevant, as Sophie mentioned, of course.
Thank you very much for this addition to my talk.
If any other one has a question, feel free to raise the hand. In the meanwhile, I actually have a question for you, which is driven by also my own personal research interest. As you are part of this group, the Hermes is mainly a machine builder for plastic recycling. So you mentioned the tool RE360. I guess this tool is extremely relevant and important, especially for workers next to the machine who are basically operating the machine. So machine operators, the quality officers, managers, the directors, maybe even the service and maintenance engineers. So I was wondering what kind of functionalities are you envisioning for the future in order to implement what is currently well known in the literature as the operator 4.0. No, we are talking about providing workers with a lot of tools, with a lot of artificial intelligence and so on. So I guess this tool, the RE360, you mentioned it, is a very nice platform to implement some technologies like this. What do you think?
We are doing a lot of work there also, not especially in the RE360, but also for the workers. So we are also working on human-machine interactions and to provide the operator the best possible way to use the machine. Not every operator is looking at the same things. So we are highly interested in this topic, and we are having a lot of work which is already running in this field. And that's the very good point you mentioned. We're also interested in defining different user levels of it. So you have the operator, you have the manager, you have, everybody is interested in different values. So the one is interested in really deep process parameters. The other one wants to have a very coarse overview about everything. And therefore, this is also be a topic which we are already dealing with, yes.
Thank you very much. So if there are no more questions, I would like to share with you also the certificate of appreciation for joining us at the ISM 2021 conference. Thank you very much again on behalf of the whole organizing committee, and also I guess on behalf of the attendees. We found your talk extremely interesting, and let me say also, if the attendees, everyone has additional questions, feel free to contact Sophie or use the interaction rooms to continue for some discussion. So I guess.
Thank you very much.
Thank you again, Sophie. So I guess we can close this plenary session with the keynote talks. So thank you all for attending this session, and we meet this afternoon European time. So in, let me say, 1 hour and a half, we will start with the parallel sessions. So there will be 5 different parallel sessions with regular and also special sessions. And feel free to give a look to the program. You will find there the link to each room. So thank you once again, and enjoy the conference.